Recall the equation of a circle is of the form that is x squared plus y squared equal r squared, with the center at the origin of 0, 0 and the radius r. So here we're talking about a unit circle. The unit circle is a circle of radius 1 centered at the origin in the xy plane, which meant the equation would be x squared plus y squared equal 1. Now, to show that a point is on a unit circle, we need to show that the point is satisfying the equation for the unit circle. So, for example, we want to show that the point P square root 3 over 2, 1/2 is on a unit circle. We need to check to see whether x squared plus y squared equal 1 or not. So then we substitute this point, the x and the y value, into the left side of the equation and check to see whether we get 1. So square root 3 over 2 square plus 1/2 square, that is 3 over 4 plus 1/4. This is 4 over 4, simplified to be 1. So we just verify that the point P square root 3 over 2, 1/2 is a point on a unit circle. Let's see, if we want to locate a point P equal to 3 over 5 y in quadrant 4 on a unit circle. So here we given x, we given y, we also given that this is a point on a unit circle. This is a point in quadrant 4. Since P is in quadrant 4, the value of x is greater than 0 and the value of y is less than 0. We'll keep that in mind. So let's plug this into our equation for the unit circle. 3 over 5 square plus y square equal 1. And we want to solve for y square in this case. This means y square equal 1 minus 3 over 5 square, that is 1 minus 9 over 25, and that is 16 over 25. Now, we just found out y square is equal to 16 over 25. This means y is equal to plus or minus square root of 16 over 25. This is plus or minus 4 over 5. Now, because P is a point in quadrant 4, which means x is greater than 0 and y have to be less than 0. So therefore, the point P have the coordinate y equal to negative 4 over 5. Let's talk about terminal point on the unit circle. Let t be a real number, and it is the distance from the point 0, 1 to the point P, x, y. This is the point 1, 0 to the point P, x, y on the unit circle. The point P, x, y is called the terminal point determined by the real number P. So this point here called the terminal point. And just same with measuring of a degree. If t is greater than 0, if t is circling counterclockwise, then t is a number that is greater than 0. If t is circling clockwise, then t is less than 0 in this case. Now, just a reminder, the x and y divide the xy plane in 4 quadrants, and the side of the terminal point is as follows. In quadrant 1, both x and y is positive. In quadrant 2, x is negative and y is positive. In quadrant 3, both x and y are negative. And in quadrant 4, x is positive, y is negative. Let's take a look at this example. We want to find the missing value of the terminal point xy using the given information. Now, we assume that this point, because we use the term terminal point here, we assume that this point P have to satisfy the unit circle, the equation of the unit circle, that is x squared plus y squared equal 1. So in the first case, we want to solve for y. We know that x squared plus y squared have to equal 1. Therefore, y squared equal 1 minus 3/4, that is 1/4. Now, because the point P is in quadrant 4, this meant that the y value have to be less than 0. So then the y value here equal to square root of 1/4 plus or minus y equal to negative a half. In the second problem, the point P negative 3/5 y in quadrant 3, this meant y is less than 0. This point P is a terminal point, so it have to satisfy the equation of the unit circle. Because y is negative, we take in the value that is negative 4/5. In the next problem, we want to find the value of x, given the value of y is negative 7/25, and it is of quadrant 4. This meant that x is positive here. Again, we use the unit circle equation. Taking square root both sides, and we'll take the positive value. Similarly, for the last problem, because the terminal point here is in the quadrant 2, the value of x must be less than 0. The next topic we want to talk about is the reference angle and the reference numbers. The reference angle, let theta be the reference angle of the angle theta. Let theta bar be the reference angle of the angle theta. Then theta bar is the acute angle that formed by the terminal side of the angle theta and the horizontal axis. What does it mean by an acute angle? Theta bar is an acute angle, which means theta bar is an angle that is between 0 and 90 degrees. So that is the shortest distance that forms from the That is the acute angle formed by the terminal side of angle theta and the horizontal axis. So for example, in the first case, we are looking at this angle is our theta. And we want the acute angle that formed by the terminal side of the angle theta and the horizontal axis, which means this angle is our theta bar. So if theta is in quadrant 1, then theta bar is equal to theta. In the next one, we're looking at this angle here being our theta. Then the shortest distance from the terminal side to the horizontal axis is this part. This is our theta bar. Again, if theta is an angle that in quadrant 2, then theta bar is equal to 180 degrees minus theta. If theta is an angle that is in quadrant 3, then this is our theta bar. So when theta is in quadrant 3, theta bar is equal to theta minus pi. And last one, when theta is an angle in quadrant 4, then theta bar, this angle, theta is an angle in quadrant 4, then theta bar is equal to 2 pi minus theta. Let's take a look at reference number. Let t be a real number. The reference number t bar associated with t is the shortest distance along the unit circle between the terminal point determined by t and the x-axis. So similarly with reference angle, if t is a number that is in quadrant 1, then t equal to t bar. If t is in quadrant 2, then t bar is equal to pi minus t. If t is of quadrant 3, then t bar is equal to t minus pi. If t is in quadrant 4, then t bar equal to 2 pi minus t. Let's take a look at an example. Find the reference angle or the reference number of the following. For A, t equal pi over 6. For t equal pi over 6 is an angle in quadrant 1. So this saying t is of quadrant 1. So this distance here is our t. This means that t bar is equal to t equal pi over 6. For t equal 5 pi over 3, 5 pi over 3 is of quadrant 4. So this is t of 5 pi over 3. So then this part here is our t bar. T bar is equal to 2 pi minus t. That is equal to 2 pi minus 5 pi over 3, and that is pi over 3. So to find the reference angle, as you can see here, our first step is to determine in which quadrant the t belongs to. And then we will find t bar accordingly. So t equals 24 pi over 7, and this is greater than 2 pi. So let's go ahead and continue and subtract 2 pi into t so that we can see in what quadrant the t belongs to. So let's start with 24 pi over 7 minus 2 pi. That is 24 pi over 7 minus 14 pi over 7. This is 10 pi over 7, and this is less than 2 pi. So 10 pi over 7, 10 pi over 7 is the same as saying 7 pi over 7 plus 3 pi over 7. So the location of 10 pi over 7 is, so 7 pi over 7 is simplified as pi plus 3 pi over 7. So here's is pi, 3 pi over 7. So this is our t. Therefore t bar is this little distance here, t bar. And because t is in quadrant 3, t bar is equal to t minus pi that is equal to 10 pi over 7 minus pi, and that is 3 pi over 7. The next one, t equal to 11 pi over 12. This is an angle that is less than 2 pi, and that is of quadrant 4. So this is our t. T bar is this small distance. So t bar is equal to 2 pi minus t. That is 2 pi minus 11 pi over 12. That makes pi over 12. In the last two problems, we are looking at the reference angle. Theta is equal to 150 degree. 150 degree is less than 360 degree. So then we can just determine the quadrant in which theta is in. So theta is 150 degrees, so that is in quadrant 2. So theta bar is equal to 180 degree minus 150 degree, that is 30 degree. Well, for the next one, theta equal to 420 degree. Well, theta equal 420 degree that is greater than 360. So I'll continue, go ahead and subtract 360 into the angle theta to see where the angle theta is. So this equal to 60 degree. So theta is an angle in quadrant 1. So this is our theta. Theta bar is equal to theta, that is 60 degree.